Let's see this question. We want to find the limit when x approaches to infinity. And this expression, x minus 3 divided by 5 plus x raised by 5x. Okay, we want to evaluate this limit if it exists. So look at this, we see x, the variable, appears in the denominator, in the numerator, and in the exponent. So first, we want to simplify inside the parentheses. So x minus 3 divided by 5 plus x can be written as x plus 5. But then the numerator, we can write as x plus 5 minus 8, because the 5 minus 8 is still negative 3. And then divided by x plus 5. By doing so, we can split as x plus 5 divided by x plus 5, then plus negative 8 divided by x plus 5. Well, this just becomes 1. So inside the parentheses, we can write as 1 plus negative 8 divided by x plus 5. So let's take the rest. Limit x equals to infinity, then this raised by 5x. So recall the definition of Euler number. That equals the limit when x approaches infinity, 1 plus 1 over x raised by x. So what is the key here? The key here is, you see this term and the exponent are multiplicative inverse. So which means if here we manufacture a multiplicative inverse of this term, which is a negative x plus 5 divided by 8, then we can only multiply by 1. So we'll have to multiply by 8, negative 8 divided by x plus 5. Because those two terms will multiply to be 1. So 5x multiplied by 1. Then let's rewrite this. So let's rearrange. Write in the definition of Euler number. 1 plus negative 8 divided by x plus 5. Then raised by the inverse of this term, which is negative x plus 5 divided by 8. Right? Then, of course, we'll have to do multiply by the rest, which is 5x and multiply by negative 8 divided by x plus 5. But this part, so this part, limit of this part, fits in the definition of Euler number. So we can write this part as an Euler number. But then we still have x variable appears here, right? Appears here. Remember, limit we can carry on to the exponent. So that just becomes a limit now, a Euler number to the power. Now we just take the limit of this expression, right? Because we can think this whole thing raised by this number. Because if we have a multiplication of two numbers in the exponents, we can do two layers. Given an example, you have x raised by 2 times 3, we can write as x squared then raised by 3. So that's what we're doing here, right? So this part gives us an Euler number, and then we can split this multiplication of the exponents into two parts. This part becomes Euler number E. Then we still have raised by 5x times negative 8 divided by x plus 5. So we just have this Euler number. Then we have to take a limit of this. So that's negative 5x times a, that's negative 40x divided by x plus 5, right? So this is taking the limit of a rational term when x, a rational expression when x approaches infinity. So we use ignore rule. Okay, so that just becomes negative 40. So this becomes Euler number raised by negative 40. Okay, let's maybe explain here a little bit. So y limit of x approaching infinity, negative 40x divided by x plus 5. Basically, we multiply by 1 again, and this 1 is 1 over x divided by 1 over x. By doing so, we get, in the numerator, negative 40x times 1 over x, we just get negative 40. In the denominator, x times 1 over x, that's 1, plus 5 times 1 over x, that's 5 over x. Now, when x approaches infinity, 5 over x approaches to 0, right? Remember, just imagine x is a huge number. You have 5 apples shared by the whole wide world people. How many apples each one gets? Almost nothing, right? So this one turns to 0 when x approaches infinity. So that's why we get this one, negative 40, right? So negative 40 divided by 1. This one goes to 0. That's just negative 40. All right, so in the end, this expression give us, so the limit exists, and the limit of such is e Euler number to the negative 40 power.